Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready, let's get started. Today we are looking at vectors. So a vector is a quantity that has got magnitude. Magnitude is the same as size and direction, which is opposed to a scalar quantity. A scalar quantity is a quantity that has got direction only, that has got magnitude only. Sorry, it has no direction. But a vector is a quantity that's got magnitude and direction. So basically, what is being shown here is that our direction are x, y, and z. K, I, and j are our magnitudes. So the magnitudes can be different, but vectors are going in the same direction, or the directions can be different, but vectors having the same magnitude. Now, when we are dealing with vectors, we have got to be able to look at certain very key principles. We have got what we call the scalar or the dot product. Is the term that you're going to hear quite often when you're dealing with vectors, and you have to be able to get a scalar product or a dot product. So if we've got two vectors, so let's say vector 1 is A, B, and C, and vector 2 is D, E, and F. Then the scalar product or the dot product, basically you're multiplying the two. You're going to multiply A, multiply it by D, so you're going to get A, D plus B, E plus C, F as your scalar product or your dot product. So basically it's multiplication, as I've said, is 1 multiplied by 3, you're going to get 3, minus 2 multiplied by 1, you're going to get minus 2, plus 3 multiplied by 4, you're going to get 12. Then you add the 3, you're ultimately going to get 13. From there, the second word or the second principle that you're going to look at is parallel vectors. So when something is parallel, it means that it's going in the same direction. So despite the magnitude, right, the direction is similar. So the rule, right, what you've got to keep in mind is that how do we identify that these two vectors are parallel vectors? So I say that vectors can have different magnitudes, but they can have same, going in the same direction. So here we've got examples of two vectors. This is our vector number 1, and this is our vector number 2. So the fact that 1, 1, and 0, which is our x, this is our x, y, and z, right? Which we said this is our direction. Remember that we said k, I, and j were representing our magnitudes, right? Then x, y, and z are representing our directions. Now, if we've got a vector, right, that is 2, which is our magnitude, 1, 1, and 0, 6, 1, 1, and 0. 1, 1, and 0, these two are representing our direction. And 2 and 6 are representing the magnitudes, which are different. So we say if we don't mind the fact that the magnitudes are different, as long as the vectors are going the same direction, right? Meaning say they've got similar x, y, and z, it means automatically that they are parallel vectors. So let's us be able to pick this up. So if you come and reverse this, if you multiply everything here by 2, you're going to get 2, 2, 0. Then here you're going to get 6, 6, 0. Right? But then if you simplify, so you might be given a vector which is not in simplified form, but you have to be able to pick it up that no, these are vectors. We can simplify this to leave it in the simplest form. So we can say factor out 2 here, then you're going to get 1, 1, 0. If I factor out 6 here, I'm going to get 1, 1, 0. Therefore, it means these two vectors are parallel vectors. So, first thing that I want to emphasize on is that, first of all, make sure that you are able to identify vectors that are parallel, even if they are given not in their simplest form. Be able to tell, are they parallel vectors or they are not. Now we've got a concept of what we call perpendicular vectors. So when things are perpendicular, it means that they form a right angle or they meet at a right angle. Right angle, which means a 90-degree angle, which is this one here, right? A 90 degrees angle. So the rule is that the dot product of perpendicular vectors is always equal to 0. Is one concept that we're going to keep in mind. So if you've got vector A, B, C, and vector D, E, F, if you're going to multiply these two, the dot product of that is going to be equal to 0. Let's keep that principle at the back of our minds. Now, we've got another concept where we talk about the modulus of vectors. So modulus basically is represented by the sign, these two vertical lines are what represents a modulus. So this sign here is what means a modulus. So if you've got a vector A, right, which is A, B, C, how do you find the modulus of a vector? So the modulus of a vector A is going to be found by use the square root of, you square each and every element of your vector. So it's A, you square it, B, you square it, C, you square it. So the square root of all that is what is going to give you a modulus of a vector. So, for example, you are given here, given that the vector A, right, is 3, 6, and 9. Find the modulus of A. This is how the question will be asked. So basically, we said we square everything. So we're going to square 3, square 2, square 9. Then all of that, you need the square root of it, right? So ultimately, you're going to get the square root of 126. You might leave your answer, right, in this form, or if you want to simplify it, you can simplify it depending on the demands of the question. Moving on to a concept of what we call unit vectors. Unit vectors is a vector that has got a magnitude of 1, and it can point in any direction, as the statement here is saying. So it can be denoted by either A, which is in bold, or whatever letter, small letter, which is bolded, or an A with a cap, as this one. These two will tell you that the question is requiring you to look for a unit vector. So if you've got a vector A, right, that is going in any direction, then the unit vector of A, right, so this is supposed to be a small letter here. The unit vector of A, you find it by the vector, you write the vector A over the magnitude of that vector. So it's the vector A as it is, right? Vector A as it is. Then you divide this by the magnitude of vector A, right? You divide this by the magnitude of vector A. So for example, you are asked to find the unit vector of A, of which A is equal to 2, 4, and 3. Now, how are you going to go about this? So you're going to look for the magnitude, the modulus, sorry, of A. So the modulus of A, you're going to get it by repeating the previous principle that we mentioned. Then from there, ultimately, how are you going to write your answer? This means that the unit vector of A, this is A as it is, 2, 4, and 3. Then you multiply it by the modulus of A as your answer. Then we are also having a concept where we are looking at angle between two vectors. Now, if we're given two vectors, which is A and B, and the angle theta between them. The formula that we use to find that is, we say cos of theta, right, is equal to, you find the dot product of your two vectors, right? So this is the first vector, this is the second vector. So it's cos of theta, vector of A, dot product of B, right? Over, then you find the modulus of A, you multiply that by the modulus of B. That's basically how you're going to get the angle theta. So this is what we've done here, right? Is the vector of A, the dot product of these two, over the modulus of, over their moduli, sorry. Now, ultimately, how are we going to solve it? For you now to get theta, we're going to need the inverse of cos, right? Cos minus 1, 7 over root of 50 as your final answer. So if you're using a calculator, you can punch this on a calculator and forget the exact and get the decimal or the approximate. But if you're asked to find it as it's an exact number, this is ultimately going to be your answer. Then we've got a concept of what we call the midpoint of vectors. So if you are given two vectors that and you're asked to find the midpoint of the vectors, basically you are going to add, right, the two vectors, then you divide the corresponding terms by 2. So if we've got A, B, and C, then G, E, and F as your, this is vector 1, this is vector 2. So the midpoint of these two is A plus D over 2, comma, B plus C plus E over 2, C plus F over 2. And ultimately, this is what will give you the midpoint, which is M. So these are examples that I was using to demonstrate to you. So your midpoint M, you write it as well as a vector at the ends. So that's it, guys, for the vectors. Thank you so much. This is the introduction. We're going to look at more videos. Thank you for now.